We're going to look at climate change. This is caused by the greenhouse effect, okay? And this is the phenomena whereby the Earth's temperature is, over the last decade, has been getting warmer. We'll see what causes this. Okay, so what we've got here is we've got, this is the electromagnetic radiation spectrum here. And you can see radio waves, they've got the lowest frequency and the lowest energy down here on the left. And then microwaves next. As the frequency increases, then you get infrared, and then the visible spectrum, the ultraviolet, X-rays, and onto gamma rays, which is the highest energy. Now we're interested in the infrared rays here. Okay, now infrared radiation is given out by anything that's warm, and the warmer it is, the shorter the frequency of the infrared radiation. Also, if you shine infrared on something, it will warm that up. So you can feel infrared shining, you know, on a hot day on your back. You can feel the infrared rays from the sun warming you up. Okay, so in this diagram here, we've got some infrared rays coming from, this is coming from the sun, and these are quite a high frequency for infrared, okay? And that means they can't be absorbed by the atmosphere. So they'll mostly just go straight through the atmosphere. But what they'll do is when they hit the Earth here, they will warm up the Earth. And as the Earth gets a bit warmer, what that will do, that will give out its own infrared radiation. But that infrared radiation will be slightly lower frequency than the incoming stuff. Okay? And this lower frequency infrared radiation can be absorbed by gases in the atmosphere. And the gases that it's absorbed by are, well, oxygen and nitrogen don't absorb at all, but it can absorb by carbon dioxide, which, as we've seen before, is about 0.03%, 0.04% of the atmosphere. And it can be absorbed also by water vapor, which is present. And it can also be absorbed by methane. Now, there are very, very low levels of methane in the Earth's atmosphere, much lower than carbon dioxide. But methane is actually particularly good at absorbing infrared radiation. So those three gases, they'll absorb the infrared emitted by the Earth, the lower frequency stuff, and that will warm up the atmosphere. And that is what is warm. That's what makes the Earth warm and habitable. But obviously, the higher the level of carbon dioxide you have in the atmosphere, the more heat the atmosphere is going to absorb, and so it's going to get warmer. And the problem is the amount of carbon dioxide in the atmosphere at the moment is increasing. Right, and this is causing global warming or climate change. Okay, so let's have a look at what is causing the increase in carbon dioxide. So the increase in carbon dioxide has been caused by burning fossil fuels, which has been going on for not very long, really. It's been going on for the last maybe 200 years, since the start of the Industrial Revolution, maybe 180 years or something. And all of this was, the carbon in the fossil fuels was trapped underground, largely as hydrocarbons. And when we burn it, we then turn it into carbon dioxide, which is going to the atmosphere. So, for example, the simplest hydrocarbon, which is methane, CH4, which is a gas, if you burn that, you'll get carbon dioxide and water. I'll just balance that. So you want 2 waters and 2 oxygens. But it's the same for any hydrocarbon. Coal is basically mostly a hydrocarbon. All crude oil is made of hydrocarbons. So when you burn any of the fractions of crude oil, that's what you're going to get. You're going to get carbon dioxide. So burning fossil fuels for any reason, most of the fossil fuels we burn at the moment is probably used for electricity generation, which is shown here. So nearly most of the electricity generated, unfortunately, does come from fossil fuels. Some of it comes from wind and solar. And generally speaking, that that leads to the production of carbon dioxide. Transport, burning petrol, diesel, and so on, that ships burning heavy fuel oil, that all contributes to carbon dioxide in the atmosphere as well. In previous days, when people used to burn a lot of coal in power stations and for domestic heating, that also contributed to the amount of CO2 being released. Okay, so is the amount of CO2 really going up? Right, let's have a look at this graph here. So we've got from 2002 to 2014, and we can see we've got the carbon dioxide in parts ppm, which is parts per million. And if you do your calculation, you will see that 300 ppm parts per million, that is equal to 0.03% if you express it as a percentage. Now you can see that the amount of CO2 has gone up from 2002 to 2014. It's gone up by a small amount. Well, it's gone up by a significant amount. And also, you probably noticed that you get this seasonal fluctuation. So it goes like this, okay? Now, the reason for that is, of course, that photosynthesis takes in carbon dioxide. So these troughs here, that will be the summertime when you've got more photosynthesis. And I think these readings are all made in Hawaii, which is in the northern hemisphere. So we're talking, the summer, June, July. That's when you're going to get those troughs. But generally, even though you do get a decrease during the summer, then the overall trend is upwards. So you might say, well, is this just a fluctuation from 2002 to 2014? Well, we can actually go back to a much longer period by using ice cores, which are taken from, which never melt. You can go back historically. You can see here they're going back to, that is 600,000 years ago, or before the Common Era, so 600,000 BC, if you want. Years, and we do get these, you get a natural fluctuation which seems to occur. But if you look here, right now, it's actually gone up to 400 ppm for the first time. Is this last bit is kind of off scale compared to the rest of it. So we're not probably just seeing one of these. We're not in one of these sort of upward bits here, where it's going to go down again. What we're seeing is a genuine increase in carbon dioxide, almost certainly caused by burning fossil fuels. Okay, right, so now let's have a look at some sort of questions which you are likely to get. These are just a couple of AQA questions, and let's have a look at this one on the left. It's got carbon dioxide. How carbon dioxide changes. We'll ignore the methane for the time being. Methane, as I said, is also a greenhouse gas. We've got fluctuations in carbon dioxide, how that's going. So that's that black line. And then on the right-hand side, we've also got, on the right-hand graph, we've got here changes in mean air temperature, okay? Which is the solid line here. And the question, well, I won't say what the question said exactly, but you had to sort of provide evidence that the increase in carbon dioxide is causing the increase in temperature. And of course, you had to say, pros and cons. Well, in favor of that, yeah, you get an increase in carbon dioxide from 1992 to 2016, fairly steady, and you get an increase in the global mean temperature. And obviously, the evidence against that is the change in global mean temperature seems to be a lot more erratic. You're getting these peaks and then troughs, whereas with the carbon dioxide levels, that seems to be more steady. So that may suggest that maybe some people may suggest that one isn't causing the other. In the question, you just have to give a balanced argument, and give an example that we've got a decrease there in the year 2000, a big decrease of 0.2 degrees C, quote that, say, but if you look at the carbon dioxide level here, that was not, we didn't get a decrease there, that was just steadily going up. Okay, so what are going to be the effects of increasing the Earth's temperature? Well, this one here is fairly important. It's going to increase the sea level, and that is due to the fact that it's going to melt ice caps, and so they're going to, rather than being out of the sea, they're actually going to be in the sea. And also it's because by water, it does expand ever so slightly when it's warmer, and so that will also contribute to a small increase. That's 1 point. The other thing is going to cause climate change. So the Earth's weather patterns are dependent on the temperatures that we've been used to. If you're going to change those temperatures, you're going to maybe change the patterns of climate. So it might even make some places colder. Overall, the temperature of the Earth will be higher, but it might actually make some places colder if it disturbs certain patterns in the weather. And also, it's probably going to lead to problems with crop failures, because areas where, for example, the Midwest of America, they're used to growing large amounts of cereal crops there. If it gets just a little bit too warm for that, they won't be able to. And so where are those food supplies going to come from in the future? Okay, so before we finish that, let's just talk very briefly about methane, which of course, methane is CH4. And it is also a greenhouse gas. It absorbs this infrared radiation, causes an increase. It's about 30 times more potent than carbon dioxide, but there are much lower levels of it. As you can see here, amounts of methane, they're measured in parts per billion. But you can see the amount of methane, that's also increasing as well. So that's also some area for concern. Now we need to know what causes the methane. Okay, the sources of methane. Well, methane, you always get some of it released during extraction of fossil fuels, because it's a hydrocarbon, and coal mines do contain some methane. You always find methane when crude oil is extracted, and some of that will escape and increase into the atmosphere. Right, so I've done those in blue because they're called non-biogenic sources. Okay, but in addition to that, you get these ones in red, which are biogenic. So that's due to living organisms, and it's mostly due to the activity of anaerobic bacteria. Now, aerobic bacteria produce carbon dioxide as a waste product when they break down biomass. Anaerobic bacteria often produce CH4, methane, instead of CO2. Where do you find these bacteria? Well, you find them in cows' stomachs, right? They have a symbiotic bacteria to break down the cellulose. So cows, they belong to a family of animals called ruminants, so buffalo and stuff like that. So the number of cows are increasing as more people, and more people are eating meat, and so that's gone up. Marsh areas, they naturally release, because you've got anaerobic bacteria there, they will also release methane. And landfill sites where human waste and waste rubbish and stuff is buried, you get anaerobic bacteria there, and that will also lead to methane. And of course, as the number of people on the planet go up, the amount of rubbish sites, landfill sites, that's going to go up, so the amount of methane is going to go up. Okay,